Um, Alrighty. Hello and welcome to our community call for Wednesday, November 19th. We've got a number of community updates, and we're going to start with basically our doc of the week, but also essentially a cool demo of the week, starting with Eric. Eric, take it away.
All right, hey everyone. We just put up, I think it went live today, documentation for installing the v2.0 release candidate 1 runtime operator. Deploying wasmCloud v2 in its RC1 form to Kubernetes. So what we're going to do here is just walk through that process, show you how you can do it yourself. So I'll go ahead and share our docs here. Looks like I have to give Zoom permission. And this may or may not work. I may have to quit and come back real quick. We'll see. Uh, is that working now?
Success! Yeah.
Hey, love it. All right. So over here are the v2.0 RC1 docs. And we've got a few pages. We're really trying to roll building this out, and that's going to keep moving quickly over the next weeks and month. But our big new thing here is on the Kubernetes operator page, we have a breakdown of the pieces that constitute the Wasm Cloud platform on Kubernetes. So an explanation of how we're using, in addition to our Wasm Cloud operator, custom resource definitions, Wasm Cloud hosts, and NATs with Jetstream, and then instructions for getting started. So we'll just walk through it live. First thing we're going to do here is set up a local Kubernetes environment, and we're going to use kind because that can give us a really smooth sort of experience for ingress and local development. So this curl command here is a one-liner that's going to download this kind config and then go ahead and start the kind cluster using that config and then delete it. So I'll bring that up. And there we go. We got our cluster. So now we're going to use Helm to install the Wasm Cloud operator from an OCI chart image. And in this case, we're going to use values for local installation that are hosted over at the Wasm Cloud runtime operator repository. So again, nice little one-liner here using Helm. And it might be worth having a look at those values to get a sense of what we're doing here. So we've got a couple of named host groups that we're going to be installing. We've got public ingress, which is going to give us ingress that we can access from outside the cluster using node port. We've got private ingress, which is going to use cluster IP. So that's going to be for our workloads talking to one another within the cluster. And then we've got just a simple default host group over here. So now we've got Wasm Cloud running on our cluster. And we can check here. We've got those three host groups. We've got NATs. We've got the runtime operator. And that's all running. So now we can deploy a Wasm component. And we're going to do that with the workload deployment manifest. So here's what that manifest looks like. Pretty straightforward. We're going to be using this hello world image. We're using the HTTP WASI HTTP interface and a little bit of config over here. We're calling our host localhost. So again, we can apply the manifest from where we have it hosted remotely on GitHub. Our hello world's created there. And we can go ahead and check on the workload. Looks good. Let's give it a curl. And we're just curling localhost with the I flag to show headers. And there we are. Hello from Wasm Cloud. So quick end to end, just 3 or 4 commands, really fast to get up and running. And we'd love for y'all to give this a try, check it out, kick the tires on RC1, and point out the rough edges, so we can keep making it better and better.
That's awesome. Thank you, Eric. One thing though is I haven't gone and updated the docs. We're actually on RC3 now. Um, it was mostly all just small patch fixes between RC1, 2, and 3. Just trying to make sure what we were showing people. Oh, well, there was one not so small thing, which was updating to support WASI WebGPU, which Mindy and Colin showed off at WasmCon. So there was one feature that got landed, but otherwise bug fixes. We could update the doc, or I might suggest that we be prudent here to just update the doc to say rc.plus. And that way it'll just be the rolling latest that we have.
I like that.
Okay, let's do that. Any questions, folks? That was awesome, Eric. Thanks for sharing.
Eric, you're so smooth, man.
Yes, smooth.
Had it all going on.
You know who else is smooth? Lucas. Lucas, you want to tell us about HTTP implementation?
You know it's not smooth, Bailey?
Me, 100%.
Delivery.
I'm probably the corniest person on the planet. I don't know. I compete with you there, Liam.
Uh, you know, amazed.
All right. Thanks for those moves. And put things on the side here. Nod your head or make some noise if you see my screen fine there. Okay, thank you. So I'm gonna talk a bit about the runtime, the Wash runtime, which powers wasmCloud v2 and HTTP and how we got here. So in wasmCloud v1, if you want to expose anything through HTTP, you bring up a wRPC HTTP provider, and that's where the routing logic resides. And with that information, you receive your HTTP requests on that wRPC provider, and requests are then sent over NATs and wRPC to an individual host. This approach requires that all your HTTP processing happens somewhere else in a different process. It introduces one extra hop, network hop, between the wRPC provider and the wasmCloud host. And it's even a bit more complicated because it's a network hop going through NATs, and every single WebAssembly call is being proxied over. This pretty much says that in order to get really good performance out of wasmCloud, we need to stop using the wRPC HTTP providers for ingressing traffic into the cluster. So this means bringing that closer and closer to the runtime. And this was a key design choice in the Wash runtime v2. And we took that at the very beginning as we can create an HTTP plugin. And if anybody needs another HTTP plugin, they can implement their own. So it's easy enough that somebody else could do it as well. But then turns out it was not that easy. And as soon as we saw the pull request from Aditya here, and he was trying to add a WASI HTTP client and WASI gRPC client plugins in a way that we detect a request is gRPC or not, and we use a different plugin depending on some information from the request itself. And as we start looking at this implementation, we realized that we had a really heavy dependency on the Wasmtime WASI HTTP crate, which was forcing us to funnel all the calls through a single interface where we needed that to be fan out to two different interfaces, the HTTP plane and gRPC. So here we asked Aditya to kind of hold hold a bit because we had a plan on how to unroll the situation. The goal is for us to have a solid HTTP implementation inside Wash that supports HTTP, supports gRPC, supports HTTP2, all the nice things, and not have people implement their own WASI plugins all the time they need a different HTTP routing strategy. So this is to say that we pretty much decoupled the WASI HTTP implementation from what you want WASI HTTP to do as a client and also as a server. So then we come over to this other pull request here. And what we're doing is we are pretty much solidifying the fact that HTTP is tightly coupled to the Wasmtime context. And this means that we are bringing in WASI HTTP as something that will always be present in the runtime, but you can enable it or disable it depending on your use case. And two things can happen. You might choose to implement a router where the only thing you are concerned about is allowing or denying HTTP requests from components, or you want to be interested in implementing a whole new HTTP stack because maybe you don't want HTTP to go out to the internet at all. You want to fake all the requests internally, or maybe you want to send all the traffic to a service mesh. So for those cases, we now have two different, for full completion, we now have two different ways to integrate HTTP with the runtime. One is I want to bring everything, the HTTP server, the client, and for that, I'm going to implement a host handler, or I'm just worried about the logic. I want to plug this into a different XDS, or I want to plug this into a different gateway on Kubernetes. So that's where you would use a router. And lots of talking. How does that look like? And what is the actual difference? And I'm going to get a diff. Come on. So this is the README for the Wash runtime. And we see here that the key differences are we are no longer importing the plugin. We're now bringing the HTTP server straight from the runtime. And we're also bringing in a dynamic router. Because we already have two consumers essentially from HTTP. We have washdev and we have washhost. We're also providing two router implementations here that show how to implement your own router even. So in this case here, we're bringing in the dynamic router. Instead of configuring HTTP plugin and adding it to the host builder as a plugin, you now construct it here, passing the router, and then you pass it in as a special HTTP handler. And you can only pass one HTTP handler. That's going to be the one responsible for HTTP throughout the entire runtime. And this way, plugins can get access to it. More things can get access to that HTTP exit point of sorts. The two key implementations here being this dynamic router for the clustered environment. And we also have the washdev router, which always sends the request to the same workload. If you don't provide an HTTP handler, that means all the outbound HTTP requests will be blocked. And this, we're doing a deny all by default exactly because you should care about enabling HTTP or not. I want to kind of quickly show here how these integrations look like. So, and this is for the case that you are implementing just the logic. You you're gonna implement a trait against this router trait here. And you have two core callbacks. One is on workload resolved and on workload unbind. When the on workload resolved, this means the runtime received an external request, it processed all the components, linked everything together, and now it's ready to start serving it. At that point, we're gonna call the router and tell the router, hey, I have a workload here that has all the components ready and it has HTTP. Go configure it, like update your internal state any way you want. And we have another callback on workload unbind for when that workload is stopped or errored or something like that. And then we have the two HTTP related callbacks, one for allowing the outgoing request. And in this case here, we receive the workload ID trying to do the request, a reference to the actual request going out. And please don't touch this, because if you touch it or consume any bytes or anything, it's gonna break. And the config, which is the Wasmtime HTTP config that was passed to the callback. This is for outgoing requests, so pretty much HTTP outgoing handler. For incoming requests, we receive the raw request, once again, as a reference, and we return back here a string, which is a workload ID. So here in the workload resolved, you have the workload ID inside this handle. You would likely put this information in a hash map that you're storing somewhere. And here in route incoming request, you would look that up. And that's essentially what we're doing here with this dynamic router. So the dynamic router gets the workload resolved, check if we have the incoming handler there. If we do, we get the host from the configuration, and we add that to our own hash map. When the request comes in, we get the host from that request, look that up in our map, and that's it. So with that information, the runtime has all the information it needs already to process this request. It already knows the workload ID, it knows the handle, it has a pre-warmed instance ready to serve. So you don't have to fiddle too much with the WASI HTTP interface itself. You just controlling the behavior of that implementation. We have here the dev router, which is kind of similar, but the only thing it does, it tracks the last workload ID. So every time there's a new workload, we just replace the previous one. Now, if you want to integrate a bit more tightly, and I mean you're implementing your own HTTP transport, then you want to implement this host handler trait here. This one will call you back when it's time to start or stop, so you can bind sockets, bring up the HTTP server, and so on. And it will also have callbacks for the workload resolved. However, it will not have any callbacks for outgoing, for incoming requests, because you are supposed to do the incoming request yourself. For outgoing requests, because this is plumbed to the Wasmtime context, we have it here. So the same way that we provide a few implementations for the router trait, we also provide two implementations here for the host handler trait. One that is a null server, and this one pretty much just blocks everything. So every time you try to use HTTP, it says, no, you're not gonna go anywhere. And we have another implementation that is pretty much the canonical implementation. It does the same thing that WASI plugin was doing up until 2 days ago. We can also create the HTTP server with TLS. All those things are kept. So it's exactly the same implementation, just a different place here. The other thing with the HTTP server, which might be worth mentioning, yes. related to the pull request from Aditya here for HTTP client and gRPC. Now we know exactly which points we need to add the gRPC logic. So if we want to do that for everybody at once, we can do that in this implementation. So instead of having a specialized plugin for gRPC, we have a flag saying, yes, this component is allowed to do gRPC or not. And we can get that information via the configuration for the component. So lots of code. This is to say also that a lot of code changed, but the behavior remains the same. Wash dev continues to work the same way, no argument changes. The only difference here is in the plumbing between wash and the wash runtime. So that we had the little interface change to add this HTTP handler here. I talked a lot. So any questions, any comments?
So can you start over again?
All right, I'm gonna talk about WASI HTTP.
Masood, I saw your hand at one point, but I didn't want to interrupt Lucas. He was definitely on a roll going through his point there. Did you have any questions that we needed to cover, or did it get answered?
Some of them got answered. This is still based on the Wasmtime HTTP, right?
Correct.
Yeah, so I saw when you were hovering over, I saw that, and then that kind of answered that question. One thing that you mentioned is that you said there is only, like, a runtime would have only one HTTP implementation, right?
Correct.
And that means that transport is a layer over that HTTP. That's what you're talking about. Meaning that I have one, but now this component needs gRPC, and that component requires, I don't know, quick, and so on and so forth. And all of them are still being supported on the back of that?
Yes. So the challenge that we were facing here is that the way that we implemented plugins works really well if the plugin doesn't require a special context binding. So if we wanted to use the wasmTime HTTP implementation, we need to use the WASI context. So we need to bind to that context. And we start going down a path of many pointers being dereferenced, many types being casted down, and so on. And we had to make a choice. We stay with wasmTime HTTP and create this second trait. This is essentially another plugin type. Is a specialized HTTP plugin type. So the choice was between continuing with wasmTime HTTP and having this special trait, or re-implementing HTTP entirely as a wash plugin. So we chose to not re-implement all HTTP as a wash plugin.
Yeah, and I totally support that choice because WasmTime is continually fuzz tested, beaten at a much broader scale that, one day I hope we'll be at. But right now, why not? Why not join efforts?
No, that makes sense. But I have a question that probably more geared toward you, Bailey, or maybe Lucas can answer that. And that's about where wRPC fits in the picture. And I know how kind of pervasive wRPC use is in V1, right? And we determined that there are, or we want to treat local versus remote differently, right? But do we still consider the wRPC to be the transport layer between, let's say, in a distributed host implementation of wasmCloud? Like, where does it fit?
Yeah, the way I'll give my answer, and then Lucas, I'd like to hand it to you too. The way that I see it is that a host is basically its own world. I hate to use the overloaded WebAssembly component term for that, but that's kind of how I look at it. And I don't really expect hosts necessarily to work in a ring together, right? When they're doing that, they should be doing some type of remote protocol. That could be over wRPC if you have two components that are remoting to each other. But the way that I see the world is you should just use either an event bus or an HTTP call, and then you get a very transparent errors and network handling specific to exactly what you were trying to do in that scenario. Where we were trying to fit different hosts, trying to fill different niches in a cluster, worked out to be, magical in the bad sense in software engineering, magical with unexpected pitfalls that you couldn't really code for ahead of time, and definitely were all of the mistakes made in the circa COM era, if folks remember that. And so I know you're trying to figure out, where does wRPC fit in this equation? I still think that it's really nice ergonomically to be able to, if you're in a completely component native system and you want to communicate over wRPC, you may want to literally have an interface that is wRPC namespace thing. And then it's very transparent to you that you're doing a wRPC style RPC call. I think that makes a ton of sense. The reality, though, for us today, like what's our 99% use case? They're doing HTTP or they're doing event bus messaging. And if we have first-class support for those two things, almost every use case that people are doing network-wise just work. And they're able to build with the libraries that they know and their standard libraries and have things just work.
Yeah, I'll kind of
So,
just
so
replay.
is it, sorry, Lucas, just one comment. Is it fair to say, and maybe you can answer that, is it fair to say that wRPC in V2 is no longer a core, let's say, feature of the wasmCloud platform?
It's not core.
Like it's demoted to, if you need, use it if you need it. But that's not something that basically is a requirement for, let's say, distributed workloads.
Correct. Yep.
Because we had also that thing about a remote provider, a provider in the new sense, right? Not the old sense, but it was that it was supposed to kind of join the ecosystem to wRPC transport, right? Kind of register itself through that. And this kind of says that that is no longer also one of the objectives.
I see that as nice to have, but not part of the MVP since we've been able to hit, again, like the 99% use case today by having people build it into their host.
Okay. Sorry, Lucas, for interrupting you.
Oh, no, all good. Yeah. So I was pretty much going to replay a lot of what Bailey said, just with a weirder accent. But I think the important thing here is that if we look at what wRPC is doing, wRPC is giving us typed width in remote calls. If we, in the external communication with non-WASI, non-WebAssembly services, that can be replaced with wasmCloud messaging, WASI messaging essentially, in that you have a publish subscribe, you have request response, you have publish and handlers. So wRPC, I think, makes sense if you really want to do width and you are okay paying the penalty of that, of all that abstraction that goes on top. If we look at how wRPC works, it essentially gets everything that is happening in Wasm, puts that into a buffer, sends that over the network, and it has to do that for every single lift and lower operation that Wasmtime is trying to do. Is quite frank, is the difference between being able to do 30,000 requests a second and 5,000 requests a second for a few protocols. So we really didn't feel like for wasmCloud v2 that everybody should pay the penalty of wRPC when all they want is to distribute workloads. So we decided to remove a bit of that facility of the auto linking and auto magical component configuration in favor of expediting a lot the performance area.
Frank?
Yeah, that actually, look, that makes a lot of sense. One thing, is where does the HTTP protocol version comes into play? Because I mean, gRPC will force you to use HTTP 2, but you still can have 1.2 and so forth. So where does it?
It's one of those it should work TM. We are using Wasmtime HTTP, and underneath is using Hyper. It's like everything from the default Rust toolset. The differentiation between HTTP 1 and 2, I'm not sure if we even should make a switch or a flag for that. I think it should just work. Because depending on the request, we know the version and we can pick a different client based on the request being issued from the component. So I really think that if everything goes fine, it should be totally transparent. If you stand up a gRPC service in a component, it will just work and you don't have to configure anything special.
Yeah, so I think today, Aditya, the Hyper server crate that's built into WasmTime WASI HTTP doesn't have the feature enabled that does the auto connect switch. But I think that's the route we should take. And what it essentially does is what Lucas just said, which is it looks at the request and does an auto connect switch based on the protocol. There was another implementation detail there, which is we had to make sure that there's a trailer TE header that gRPC requests use to make sure that that is allowed to be passed all the way through, and it is now both in the WasmTime WASI HTTP, but also per the WASI HTTP spec itself. I think a very important salient point about WASI HTTP is that it's intentionally protocol agnostic. We wanted it to be virtualizable across all of these different types of protocols to make it work for all of these different environments. So in theory, you can do 1, 2, and 3 if you're in a 3-like environment.
Oh, as long as you have UDP. Okay, thanks.
Awesome. And we feel like with this, we're pretty close to closing the scope for wasmCloud 2. So we probably have to cut another release candidate here and stabilize, write more tests, bring ChatGPT into the picture. But I think this is kind of the final cleanups here before we have an actual V2 release.
Lucas,
Yes.
I didn't raise my hand, but I have kind of a follow-up to what Frank was asking.
Sure.
And that's the fact that, yes, most of us, at least on this call, if not all of us, know that Wasmtime right now supports P3, right? And HTTP 2 is really something that comes with P3 for WASI, right? So, is it correct to assume that, let's say today, because Wasmtime supports HTTP 2, there isn't anything on the wasmCloud side that prevents us from opting for P3 features?
Okay. It's actually funny that you led us into this because I had this on the agenda to talk through the differences here and what the rollout's going to look like.
Awesome.
Okay. I wish I had more notes though, because that's a really good detailed question that's related to what Lucas was working on. I want to highlight actually that WASI HTTP P2, WASI P2, WASI HTTP there, we made a patch update to define that that TE header that I was talking about is allowed. So WASI HTTP P2 is virtualizable for HTTP2. Now it matters on what your server implementation does, and what we are highlighting is our server implementation doesn't do it yet, but that's configuration. That's compiling things in. That's easy. That's not standards work. That's stuff we can get done quickly, right? So whether we do that as the way that we embed and build WasmTime, we've got options for that backend. Of course, my preference is always where we can, let's upstream it all the way up to WasmTime so we all have a shared awesome implementation. But essentially your question is, when is that server part going to land? We don't know quite yet. We got to investigate a little bit more for what to flip on to make sure HTTP2 works, like what Aditya and I were chatting about in the chat. But once we have that, I think it'll be very quick. However, let's talk about WasmTime P3 and what that means. Well, good news in the community is that Mozilla at the W3C in-person meeting showed off their experimentation using the WebAssembly component model for Firefox. And they got really excited about it, and they gave this awesome presentation where they did a deep dive on why it really matters to them that they want this and they want to start working on it. And I think my favorite part, who's giving the talk, Ryan Hunt, who's a lead engineer for the Firefox WebAssembly team, is that he pulled up, the Cheeto site, Hacker News, and was like, they're always giving us a hard time. We did this awesome thing with WebAssembly 3.0, and the first thing was, where's my DOM at? And so this is basically going to be their answer for that. Now, Luke spent a good bit of time deep diving on what they would exactly need, and we learned of basically a scoping case that's going to be really important for the browser implementation. Wasn't as important for our implementation and didn't come up when we were implementing P3. This is a lot of preface for, we found a design change that we had to make during implementation. We've begun rolling out that design change, but what that means is that P3 components that get produced off of main today are incompatible with both WasmTime 38, which is the current main. WasmTime 39, that's going to be out soon, won't be in that one either because we cut that release 2 weeks before and continuously fuzz it until the release is out. So we don't add extra code to it unless we absolutely have to. So 40. WasmTime 40, I think, is going to be the one that we're going to be aiming to align around on P3 across the whole ecosystem. I hope that clarifies on when my expectations around when WebAssembly components with P3 will be out. I do want to highlight that Roman just did the major upgrade to WasmTime 38 for both wasmCloud v1 and for wasmCloud v2. And we've just merged both of those changes as of yesterday. I am aiming to get a patch out for wasmCloud v1 this week, and then also the next release candidate, and both of those will be on WasmTime 38. Just in time for next week to update to WasmTime 39. Questions on that front?
Just tears, no questions.
Yeah.
Maybe you said that I missed it. When 40 is expected to be out?
So we release a new version of WasmTime every month. So 39 is basically November's, 40 is December's.
Okay, so in December we should be able to start writing async components.
You could, if you're game to build off of main, you can start today. But it's building off of main in a lot of places, like a lot of places. And I can actually show you a little bit of that. I do have some of that running actually. But yeah, you can see kind of just the release process for WasmTime. It's very regular. It's on the same days every time. And then whenever we get a CVE, we put a patch out. That's part of the reason why we're driving so hard on getting Wasmtime 38 out, is so that we can have our CVEs patched. Yeah. Thanks, Frank. That's probably better than Bailey GPT, but yeah. December 20th, although actually I'm gonna my bet is actually it'll be the well, yeah. We'll see if we do something different depending on the holidays. Usually it's the 24th. Okie dokie.
But that means, sorry, I'm just asking from a WasmCloud perspective.
Yeah,
right? So if I build off the main of Wasmtime, is there anything in WasmCloud that, let's say I'm talking about V2, because I want to do, I want to start porting some of my stuff to V2. I understand the architecture of the V2, at least at the high level, right? And async is something that I have kind of worked through by providers, right? In V1. And now if I do plugins or do regular components, still they are components. So and that means that if I want to use async, then I need to also know that WasmCloud allows me to leverage async, and that's kind of my question is coming from.
Yeah, well, you can get started with wasmCloud V2 today and just use WASI P2 components. We'll have a really easy way to upgrade from WASI P2 components to turn them into P3 components. So similar to our adapter technique that we did for P1 to P2. So you don't necessarily have to build from source to take advantage of that, but you're gonna want to, because the main difference between P2 and P3, async is actually not the right word, even though we've been saying that, but it's a good generalization. The main difference is actually now we have the primitives that we can bind to in our language bindings. So in your guest code, you can much more ergonomically and easier write async code. It's not necessarily that async wasn't supported, because actually we had async via callback technique built into WASI-IO. So P2 does support async, and that's also part of the reason why things like HTTP2 do work on WASI P2 today.
No,
Yeah.
I have done that, and I have used pulling and those, right? But that's really still you're doing some blocking stuff in order to wait for the response, and that's why I'm looking for the ergonomic way of doing the operation.
Yeah, so we're going to depend on Wasmtime. I'm expecting Wasmtime 40 to come out at the end of December, and then we're going to basically immediately turn around and build that into our WasmCloud Wash, V2 build. And at that point, we would need to turn on a flag to make it available. I think I would still put it behind a flag, so you would still flip it on. It wouldn't necessarily be on by default until we hold the vote that says this is the next standard. Because, it's still technically not, just because Wasmtime's implemented, it doesn't mean that we've passed it through, or that there aren't any more incoming changes. I don't expect there to be. And they will get a message from me if I see anybody trying to propose more changes. But yeah, so let's just say together, our goal is probably end of January for us to have a full release. I don't want to promise any sooner.
Do you have a stories for that? I mean, again, we can contribute, because again, we need to follow your kind of design lead, right? We need to design things, and then we can help with the implementations.
Well, the good news is that as far as our WasmCloud implementation is concerned, we're not concerned if it's P3 or P2. That is totally transparent to us. We just run those workloads to whatever we've configured Wasmtime to be able to run.
Okay.
Yeah, so all the stories, I definitely have the folks working on it. Speaking of which, Victor, for example, is working on the second reference implementation, who he's been giving us regular updates every week here. and I think has made some really good progress this week discovering one of the key differences. He's one of the areas that we need to have done to be able to advance it as a standard, which is the second reference implementation of taking these interfaces and making it work in a Node.js environment. And he's been making awesome progress. So once we have all those test cases completed and he swallows this next design change, sorry, Victor, we should be there. So yeah, all those stories are tagged out in the WebAssembly component model repo, the subsequent WASI repos, and then and inside Wasmtime, and also Jaco. So lots of places, but they're all moving. Nothing's blocked. Okay, that was a lot, you guys. Any more questions on just that one? Or I guess these two combined on, we're getting a patch update, we're moving on Wasmtime 38. We'll move on Wasmtime 39 within a month and Wasmtime 40 within 2 months.
Yeah, I think the feedback that we're hearing here is a bit more on the path to V2, like what are the remaining tasks, what is left out, and we will get on that. There's also a conversation about where is this gonna live, wasmCloud versus Wash repository, and we'll have some discussions on GitHub and go from there.
All right. Since this stuff is all... Oh, yeah, go ahead.
I have a question for Lucas. I have meant to ask him in 3 meetings. I have been in situations that I couldn't speak. Lucas, what is the relationship between wasmCloud and Kubernetes?
So I think we are using Kubernetes as the standard scheduler that we don't have to write. What I mean by this is Kubernetes is really good at being a scheduler. When it comes to WebAssembly, the challenge is the cardinality of things that you need, pods, IP addresses, and so on. So what we did is we are using the Kubernetes API simply as a scheduler, a place to store data. This doesn't mean that wasmCloud only works on Kubernetes. And it also means that we can run wasmCloud in way more places than before in a few different ways. First, we run everywhere Kubernetes is available. So AWS, AKS, GKE, all the cloud runtimes. Then we have the situation where you can run a K3s API server, just the API server, and point the Wasm Cloud operator and hosts to it, which means you can literally place a bunch of Wasm Cloud hosts in your edge network. They will all be talking NATs, but you're managing everything from a central location using kubectl, and that's pretty nice. And then we have the other case, which is I don't like Kubernetes. I want to implement in my own scheduler. That's why we have all the protobuf information now being available, and also all the Go code that is inside the runtime operator. So you can literally get that and implement your scheduler on top of anything you want. You want to store your workload definition in Redis? No problem. Static files? No problem. So we pretty much decoupled many layers of wasmCloud here, where at the host, you have plugins. At the runtime, you have plugins. For the scheduler, you have plugins. They all mean you need to write some glue code to get there. But this is also good because then you're providing your own artifacts, keeping your own intellectual property, and so on. So sorry for the mini sales pitch.
No. So I'm a Kubernetes with me, right? Basically, that's my daily job. But the reason that I was asking was that, like, this new relationship between wasmCloud and Kubernetes is not, at least in my point of view, from my point of view, is not fully articulated, right? Kubernetes is not being declared today as the primary platform. right? But still, I think for a lot of people in the community is viewed as when you have like large scale workloads and those. And what is the situation when you're running wasmCloud, at edge, right? Especially when you have a lot of edge and you want to kind of run it in such a distributed way. Does it mean that now you need to have a lightweight Kubernetes cluster running at edge that host wasmCloud, or basically you can have this dual mode that you use Kubernetes again for large scale things or main things, and then you have other solutions that when Kubernetes is not a good fit.
Yeah, Kubernetes is not mandatory. It's really that we had to align on something, and Kubernetes is the incumbent. So it's one of those that if you are in the Nomad camp or the Kubernetes camp, sometimes they're like, I don't like each other. But ultimately, Kubernetes won the scheduler war for the best or the worst. But here we are writing YAML. And also addressing a bit of your this question there about what do we mean by scheduler is anything that is responsible for placing workloads on hosts. So at that point, you collected all the information, you know which WASM artifact you want to download, and you're like, I want to send this to host 1, and I want to tell it to start this workload with this HTTP host configuration and so on. It's really targeted, different from what Wasm was doing, which is a bit more sending a bid for hosts to say if they can fulfill that or not. It's also not to completely close the door for Wasm being updated to have this V2 interface. Not very interesting. And why is that not very interesting? The OEM spec is pretty much dead. From the OEM spec, the interesting parts that are in Wasm are related to the wRPC providers, which is not in V2. So what's left in the Wasm OEM spec there is essentially the component and link configuration, which is also not in V2. So there's very little overlap there, but we could make it work. But I really expect here the next wave of schedulers to be mini schedulers, like a Redis scheduler, something that is tied to other applications that already have a pass. So Doku, for example, could benefit from something like this. And with this, we're going to cover Wash Dev for developers, Wash Host for your clusters. And we've been thinking about another one called Wash Serve for your build pack environment. Let's say Heroku. I want to deploy components to Heroku. How do I do that? Well, you use the wasmCloud build pack. And that will not need a Kubernetes cluster or anything to bring up that workload. So, but this I think is something we're going to look at right after we land the wasmCloud V2 bundle. Should be pretty quick.
Yeah, on that front, for just the last thing you just said there, Lucas, I think you could just imagine a a standalone use case, and that's where you would put the wash serve command. Then the other thing I just brought up was we were having this really great conversation in Slack. So folks, if you want to chime in there or add more details or help us make some of these docs and explanations real, obviously super welcome. This is a sketch I put together really quickly this morning. Lucas, would you roughly say this kind of maps? I realize that I need to include basically the wash runtime to describe how this piece works. 'Cause I didn't add that there. But I think folks think that there's a scheduler, and there kind of is, but I would honestly call this the reconciler. You know, instead. And that's really all it's doing is saying, this is the state I'm supposed to be in. Yo, host, do this.
Yeah, that's correct.
Yeah, reconciliation is more like how I see it, Bailey, than a schedule. It's like get this thing to be that thing.
Yep. Yeah. So it's a vast simplification, I would say, in comparison to what we had at V1, for the better.
I draw now, you know.
Hey, by the way, isn't the HTTP module now part of the Wasmtime? I mean, if I go back, so it's embedded now, right? Or
Yeah, so I
if I
obviously
was
stole
paying
an old diagram,
attention,
so I need to update it. I think there's well, it's like a cake, Wasmtime, where you've got this cool spot where you've got the store and the Wasmtime instance. That's the thing that actually provides the sandbox for like the WebAssembly runtime bits. But then there's this other side that's just like straight up native code, and it's kind of hard to describe that layer of the cake. But if you could think of the WebAssembly components sitting at the very top of the cake, maybe you got like little figurines and they're getting married or something. But and then all the way down, there's many more layers for the types of implementations that you can implement. With the bottom layer actually being us wrapping the whole thing. That's probably too abstract. I need to stop. I'm with Lucas on the onions thing because I see Ian's on here who I really jived with the MCP servers should be like onions blog post, which was really good to read. Yeah, we got better, more diagrams incoming. All to say, the HTTP server implementation where that's actually wired up is at a totally different layer than what people would canonically think of as the WebAssembly sandbox layer. Well, we're out of time, but this was a really great discussion and conversation today. I've got a cool demo that I'm going to save for next week, but it involves C++, which is very exciting. So stay tuned for that. Yeah, it made me want to cry, but also it was really fun, if you can believe it. Yeah. Okay. Thanks, everybody. Have a good rest of your week.